Welcome to Bald Spot Math. You've done a lot of plotting of points on a coordinate plane, whole numbers, integers. Today we're going to look at rational numbers and the coordinate plane, and also reflections on the coordinate plane of different points. Let's get started. So, coordinates don't have to be and won't always be integers when you're plotting those points on the coordinate plane. You need to know how to plot also with rational numbers. And of course, rational numbers are any number basically that you can make a fraction, a over b. So, when you plot these points, it's not as easy sometimes as plotting integers and whole numbers. But you can do a couple of different things. You can estimate where a point should be. So you've got your intervals and you're just kind of trying to find the best fit. Sometimes that's good enough. Other times you can build your coordinate grid with intervals that make plotting rational numbers easier. You don't always have to do your intervals 1, 2, 3. Maybe you're going by quarters or halves or fifths. Whatever makes sense for your data. So let's take a look. Alright, so this is an example of a coordinate grid that is plotting fractional parts, rational numbers. Alright, so you'll look at point P, and you've got, first of all, you see your x interval is going by halves, and your y interval is also going by halves. And what they've done here is you've got the point negative 1.5 and 3/4. So they've not only broken down this coordinate plane into fractional parts, they still had to do a good estimate of where that point should be. So this is combining both methods at once. But essentially, it's still the same as plotting integers and whole numbers on a coordinate plane. So, pretty basic. Now we're going to look at a reflection. So, reflections are just what they sound like. When you look in a mirror, that's a reflection. We're going to talk about basically mirror imaging points on a coordinate grid. Later on, you'll learn about reflections of figures, polygons, different shapes on a coordinate plane as well, also called reflections. So, there's a lot going on in this graph. I tried to color code it for you. Let's look at points A and B first, A and B. A and B, the coordinates only differ by their y-coordinate signs. You'll see that this is a 5 and this is a -5. That's the only difference. That means the points are reflections of each other. When the y-coordinate sign is different, the points are reflected over the x-axis, meaning they can flip over the x-axis. They're reflected in this way. If you look at points C and D, you'll notice that they differ only by their x-coordinate sign. We have a negative here, a positive here. They are reflected over the y-axis. And last, you'll notice points E and F. They differ by both x and y. You have -8, +8. +1, -1. It's a double reflection. They're reflected over both the x and y axis. And the key to this is essentially just memorizing what the different signs mean as far as reflections go. That's it.